Water scarcity is such a big issue, and it will be forever. Agriculture uses the majority of the water because they need it to produce food. And there's a lot of pressure on agriculture to do more with less.
Farmers in Utah and Idaho are facing water issues. We're on a groundwater management plan here, and me and my children are looking at a future where we have fewer water resources.
In the Cedar Valley alone, we're overpumping by 8,000 acre-feet per year. That's almost 2.5 billion gallons a summer overpumped.
Every farmer that I've talked to is very interested in figuring out how can I keep my business viable while reducing my water footprint. And we've been able to provide some approaches and technologies that help them address those concerns.
When I first came to Utah about 8 years ago, it was shortly after I arrived that we saw the need for water conservation in our state. This was about the same time that Western SARE was opening up their first long-term proposal opportunity. It's been about 7 years ago, and we've done a lot of great things since with the support of SARE. So we really wanted to look at 3 areas of water management. So we started studying different methods or approaches, technologies for irrigation management. We also wanted to look at the crop and the soil management. So deficit irrigation strategies for crops, also looking at different crop types, and then wanted to look at alternative crops, crops that might use less water. And then with soil management, a few of the things that we've tested are tillage and then also the use of cover crops. And then see which combinations of how we manage the water, how we manage the crop, how we manage the soil, and finding the ideal combinations to result in the most efficient use of water. So that was one question. The second was related to it, and that was what happens when we put the best everything we can. So the best irrigation technology, the best crop management, the best soil management, when we put them all together, do they stack? Do we see cumulative or additive benefits? The other piece of it is led by Neil Hansen at Brigham Young University, and that piece is looking at precision irrigation.
Our team is specifically looking at the concept of variable rate irrigation. This applies to center pivot sprinklers. These are very big sprinklers. They cover a lot of space, and they're beautifully engineered to apply a uniform rate of water on the field. But the challenge that we're trying to address is those fields are big enough that they're not uniform. So some of the areas of the field end up getting over-irrigated, some get under-irrigated, and we're trying to help identify technologies to apply the right amount of water as that pivot is traveling. So that's the idea of variable rate irrigation. We use digital sensors, install them in the soil at multiple depths so we can actually sense what the plant roots are sensing. We also install a small weather station in each field. It allows us to get information on rainfall, humidity, temperature. So we can add that to what we're learning from the sensors, and it's local to that field. With the combination, we can tell how much water we need to apply just to fill the soil up to its full point. We don't want to overfill it. When you overfill the soil, that's when you start leaching water and wasting water, and you also lose nutrients out of the soil because the water carries it away. So these sensors benefit the water, but they also benefit the plant nutrition.
So in this work, we're focused mainly on sprinkler irrigation. Sprinklers that would be attached most commonly to a center pivot. So what a lot of producers use is what we would call a mid-elevation sprinkler. And it's typically 5 or 6 feet off the ground. But about a little over 2 decades ago, there were some technologies that were developed called low elevation sprinklers. And we've actually looked at 3 different types of low elevation sprinklers, compared them, and then also looked at drip irrigation for center pivots.
So here at the SUU farm, on our linear, we irrigate with LIPA system, which is low elevation or low energy precision application. In Cedar City, we have a lot of wind, and so we lose a lot of water. But when we can get the water down there closer to the ground, sometimes the nozzles will even be down inside the plants, with almost zero evaporation happening.
So a lot of the testing that had happened with these low elevation sprinklers was tested at the same irrigation rates, which is good, right? But if a sprinkler is more efficient, the hope would be that you could reduce water application. You could reduce irrigation. So that's what we've been trying to test. So in our trials, we have full irrigation and then we have reduced irrigation. So we apply 75% of the water, 50% of the water, and then we have another treatment that's also 50%, but we try to target the stress. So instead of putting on half the water all season, we try to still use half the water, but target it to more sensitive or less sensitive periods of crop growth. So that's been a lot of our testing and has showed a lot of great things. So in a lot of cases, we can put on 25% less water and still get the same production. One of the greatest examples maybe is Tanner Holt and the Holt farm. In the last few years, they have converted to low elevation sprinklers on almost 10,000 acres.
Our irrigation project primarily consisted of putting meters on the pivots so we could measure consumptive use, and also on putting LIPA irrigation on the pivots. We have reduced almost 15–20% of water application on our alfalfa crops. From our perspective, it's vital for us to be involved in the research and progression. What if we find something now that just makes a 10% difference? Well, every year that we don't take advantage of that, we're falling behind. And on the other hand, if we can do it now, the savings on that, whether it's water savings or fertilizer savings or whatever it is, to get those gains now is what puts us ahead, especially in today's economy. Commodities aren't worth as much. That 10% is the difference between staying in business or going out.
Part of what we do is engage our students in this project where they're meeting the farmers, they're involved in the research, and it's just such a great place to help develop some of the future agricultural professionals that will work in this field.
Traditionally, as an undergrad and now a graduate student, there's very little interaction with the real world. We're generally messing with either synthetic data or data that we're far removed from, but being able to meet the farmers, hear their concerns with how they're applying water, and being able to use that information to fuel our research, to better our understanding of how to leverage VRI to help farmers has been super helpful, not only from a student perspective in learning about these actual issues, but also as a researcher and how we can better solve these problems.
We have studied some crop management practices, the drought-tolerant genetics, and have not found a lot of promising results there. The alternative crops have been really promising. In a lot of cases, we've seen that they can use half or 75% of the water that other traditional crops might use. The no-tillage and the cover crops, I think the jury's still out a little bit with those, but we haven't seen a lot of the stacking. That was one of our initial hopes, is that we would see, with one water conservation practice and then another, that you just see those additive benefits, and we haven't quite seen those yet. I'm hoping with time we see some more of that. There are a lot of long-term studies in the United States, some that go 100+ years, but I'm not aware of any that study irrigation. That is one reason why this work is so important. In a lot of places we don't have enough water, and when we don't have enough water, agriculture cannot, in a lot of cases, thrive and survive. And so I think it's so critical and important that we look at what are the effects of irrigation management, the interactions of irrigation and crop and soil management over a long amount of time. We have to understand the long-term trends and impacts if we want to effectively deal with drought and water scarcity. So we do plan to apply for another Western SARE project.